Good morning, everyone, and thank you very much for joining us for today's webinar, Single Exit Stair Building Design, Alternative Solutions and Code Development. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions that you may have for our speaker there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow just a few weeks for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm excited to introduce our speaker for today's session, Conrad Speckert. Conrad is a designer and building code expert based out of Toronto and is principal at Semibold Solutions. Conrad was awarded the Canada Council Prix de Rome in architecture and the RAIC Medal for Research and Innovation with LGA Architectural Partners in recognition of recent efforts to improve the quality of multiplex and mid-rise housing across Canada through zoning bylaw and building code reform. So please join me in welcoming Conrad Speckert.
Thanks, Shalika. Good to be here today. I see we've got quite a large number of participants, so that's quite exciting. What I'm going to do today is walk you through not an extremely detailed presentation of the code change, sort of technical conditions and stuff that's being developed. If you want to get into a very detailed discussion about things like, smoke control measures, time egress analysis, risk assessment, etc., then, take note of my email address and feel free to email me and I'd be happy to discuss. But what we're going to really look at things today is from an architectural perspective. As Shalika mentioned, I'm a code consultant, used to work at LGA on a lot of missing middle housing type work. And currently, I'm a member of the National Model Code Task Group on single egress for this code cycle. So just start jumping into this. So what we're going to do is have a bit of a structure where we look at answering the question of what is single stair. To many of you, this may be your first time hearing this, well, maybe not your first time hearing about it, but your first time really seeing it visualized in the Canadian context. We're going to see a bit about whether it's a new idea or if we've been talking about it for a while. We'll look at the code. We'll look at what other jurisdictions are doing. We'll look at some pilot projects and prototypes. Then we'll zoom in out a bit and look at sort of macro level economic housing supply impact, talk about the code change requests, risk, and have lots of time for Q&A. I'm going to try to talk for an hour without putting you guys to sleep. Hopefully we can do so. Certainly with audiences of architects at the OAA conference 2 years ago. That was quite fun. I've since then done this type of presentation with building officials, fire engineers, and yeah, so it's always nice to do this in front of an audience of architects because, of course, you guys can read the floor plans much faster than some others can. So let's get into it. So simple question. What is a single exit stair building? And one of the things is that sometimes when we hear single stair, or people have described it as one way out, no way out, or reducing and deleting the requirement for two stairs in buildings, it's a bit of a misnomer because a single stair building is a fundamentally different type of building than what we're typically used to when we think of apartment buildings. We're dealing with a very limited number of dwelling units on each floor, extremely short travel distances from the unit to the staircase, a limited number of occupants per story, and a limited building height. When we compare that to what we typically see, I mean, I live in downtown Toronto, in the urban context across Canada. We're very familiar with the efficiency of a double-loaded corridor apartment building, except for on the corners. The dwelling units in between are, we call them shoe boxes. We've got borrowed light bedrooms, windows on one side, leads to more reliance on mechanical ventilation, less daylighting. The travel distance in that hallway can be up to 45 meters to one of the two exits. And other than exit capacity, there really is no limit on the number of dwelling units or occupant load on each floor. And what is the goal of single stair design? So the way I see it is it's three parts and each one leads to the next. When we're talking about the missing middle topic, which I'm assuming all of you are familiar with and have heard ad nauseum just being described, it obviously makes missing middle housing easier to build. That leads to making the development of smaller sites feasible, things like orphaned lots, narrow lots. And that also changes not just what we build and how we build, but it changes who is building, because it enables development for things, for small scale housing by people that we might call citizen developers. These are the types of developers that don't have the large amounts of capital and time that's required to go with land assembly and to pursue high-rise construction. I could also add a fourth one to this, which is that it changes the carbon emissions profile, both embodied carbon and lifestyle carbon of the people living there, being in a more walkable community and building at a scale where low wood frame and mass timber construction is possible. Now, of course, one of the major concerns with single stair, and certainly as fire chiefs have described it as removing an exit, is the topic of safety, both fire and life safety in fire emergencies and all types of emergencies. We really have to understand what is permitted by the code, because as we know, in the context of alternative solutions, we're always comparing it to what the minimum level of performance is that's in the code. And so this diagram, when you look at the variable of travel distance, tells you what the Canadian code determines to be safe. A 45-meter travel distance in a hallway with 6-meter dead ends means you could have a hallway that's up to 102 meters long. In the context of single stair, it would not be possible for the hallway to be more than 12 meters long. Some Americans down south, realizing that they needed a visual, obviously related to sports, to communicate this concept, and maybe I'll make a version of it with a hockey rink, shows the maximum permitted travel distances in the IBC compared to what's permitted in the Seattle Building Code. And it's a pretty quick, easy way to understand the differences in probability of fires occurring, probability of what we call fire alarm fatigue, because fire alarms are going off often as a nuisance alarm and then people aren't responding to them, the number of kitchens on each floor, etc. And when we turn to another variable of occupant load, number of dwelling units, the National Building Code tells us to consider occupant load on the basis of exit width. And so for those of you that are familiar with that calculation, in Part 3 of the code for buildings of 4 to 6 stories in height, the code allows you to have up to 275 people per story. That could be up to 137 bedrooms on that floor level, and that's per floor. When we look at the context of single exit stair and the basis of the code change request that is being looked at the national level, and is similar to some changes I'll talk about in British Columbia and Vancouver, we're not talking about more than 30 people on each floor. And so cumulatively on the 5 upper floors of a 6-story building, that's 150 people. It's just over half of the number of people in the entire building as are permitted on a single story of a 2-staircase building. And of course, we also are talking about limits on the number of dwelling units per floor, which inherently reduces the number of kitchens, the number of sources of fire ignition. But one of the interesting things is if you look at only occupant load and travel distance, you can end up with a very large building area. And so when we're talking about risk assessment and understanding single stair in the context of Canadian buildings of 4 to 6 stories in height, we're often also mindful of being agnostic to construction type. And so what that means is understanding things in the context of it being possible as non-combustible construction or combustible construction or mass timber. The lowest level of performance, of course, being a wood frame building. And so when we look at what's in the code currently, I'm sure that all of you are familiar with the articles in 322. At 6 stories in building height, the maximum building area in a wood frame building is 1,500 square meters. If we apply a typical building depth of 20 meters, that tells us that building could be about 75 meters long. If we're only at 4 stories, I just realized I flipped the numbers here on the slide deck, so apologies for that, but the 4-story drawing is at the top and the 6-story one's in the middle. That building area increases and the building length increases. Again, comparatively, when you're looking at a single stair building based on the work that's being done at the National Model Code level, it's being discussed at the scale of not more than 600 square meters. And 600 square meters is a very familiar number in the context of small buildings and small building areas. And zooming out a bit from the numbers and the quantitative side, this is what's kind of interesting about single stairs. When we look at the context of apartment buildings in Canada and North America today, this is what they feel like. When we go into the building, we, from the lobby, see a row of elevators. We go up, we see a long hallway. The exit stairs are not used on a daily basis. The exit stairs tend to be unfamiliar until they're needed. And an apartment building typical floor is pretty indistinguishable from a hotel. So hope that gives a very quick introduction to single stair. Now we're going to look at a bit of a history of this topic in Canada. So back in 1984, 2 architects put together a report for Canada Mortgage Housing Corporation, which reviewed fire safety and the design of apartments. They looked at fire statistics in Sweden and Finland, apartment building designs in other parts of the world, what was in the US codes. And the report spoke to the topic of single exit stairs, something that they would recommend for work to be developed in the Canadian context. Of course, that was at a time when the number of apartment buildings we were building, the type of planning policies and land use permissions that existed was very different from today. Then in the 1990s, obviously one of Ontario's most renowned architects, Eb Zeidler, had also written about this subject and saying that if there was a goal to unlock main streets, buildings on avenues and major streets, that one of the main issues beyond parking requirements, what he argued in that essay was that the second biggest topic beyond parking requirements would be the requirement for 2 exits, and recommended ways to address that. And then in 1995, and this is very exciting when I came across this document. In 1995, the Ontario Ministry of Municipal Affairs and Housing worked with Toronto Buildings, Toronto Planning, and Toronto Housing Secretariat to put together a report on Main Streets development. And it was a report recommending 29 things that could be done in 1995 or 1990s to unlock more Main Streets mixed-use buildings. Some of those recommendations have since been implemented, and some of them have not. And so it's a very interesting moment in time to capture what was being discussed even in the 1980s and 1990s. More recently, in 2010, when the City of Toronto did its Avenues and Midrise Building Study, in the consultant's report to that, which Brooke McElroy Planning had worked on, there was a recommendation that for many of these buildings, there should be a consideration to allowing single exit stair design. The OAA also in 2019, as part of their report on housing affordability, Fortunately, only in italics, very faint text, mentioned potential changes to the Ontario Building Code to permit four-story buildings with a single exit. And then most recently, the report of the Ontario Housing Affordability Task Force back in 2022. One of the items in that document was also to recommend allowing single stair buildings up to 4 stories. It is now 2026. There have not been any provincial consultations or reports published on this topic. And so it's interesting to see what was at least discussed back in 2022. In other provinces, however, British Columbia moved quite quickly. Some might say too quickly on a process of changing their code in 2024 to allow buildings up to 6 stories. Vancouver, which is an interesting case because Vancouver is a chartered city, so it has the ability to write bylaws that contravene provincial and federal legislation. And so Vancouver has its own building bylaw, essentially its own building code. And Vancouver, on their own pace and with a very thorough consultation process, went and developed permissions for single stair buildings of up to 6 stories with requirements for the exit stair to be an exterior stair that's also protected from the spread of or from the accumulation of ice and snow. And really, it's an excellent solution to address smoke spread in the context of Vancouver's temperate climate. And then bring it back closer to home. Following a city council motion on this topic, the City of Toronto Buildings Department put together a guidance document for single exit stair alternative solutions. And the City of Edmonton also passed a city council motion. Again, both of these jurisdictions live under the provincial building codes, can't write their own building codes. And so alternative solutions is the way in which construction innovation can be led at the local level. And in Edmonton, a fire protection engineer and an architect produced a guide for single stair alternative solutions, which was actually quite interesting because they really looked at how it would align with recent zoning bylaw changes as well. And several projects have since been approved in Edmonton. But of course, in order to talk about alternative solutions and code changes, we really need to understand the history of the code. Anytime we want to go and look at updates or reconciling something, it's the Chesterton's fence argument. You can't tear down a fence until you know why the fence existed in the first place. And so the National Building Code, both in Part 3 and Part 9, state that a floor area in a building not more than 2 stories in height is permitted to be served by 1 exit, provided the total occupant load is not more than 60 people. As soon as you're over that occupant load, the travel distances, the floor area limits, and the 2-story building height, you're required to provide 2 exits. The only exception to that, of course, as many of us are familiar with, is stacked townhouses, where the staircase is internalized within a dwelling unit. Just gonna take a sip of water here before I get into the nerdy part. So, as many of you know, the Ontario Building Code has existed since the 1970s. The first edition of Canada's National Building Code was published in 1941. It was heavily based on a review of permissions in US codes and British codes and documents that were published at the turn of the 20th century. And this document is a very crude analysis, but it just looks at the page count of the PDF of the code. NRC has been very kind to put out an online version of every edition of the code. And of course, what's been interesting is that since the early 2000s, essentially once we digitized things, the length of the PDF itself became not really a barrier to iteration of the code. And so it's on a trajectory towards increasing length and complexity for better or worse. Other codes in other jurisdictions put more of the rules and standards and technical guidance references. Some codes like the NFPA 5000 code breaks things out by occupancy category and building type. And so it's really impossible to compare or kind of make a statement broadly that building code length between different countries results in different outcomes. In every country, it's a different, in every context, it's a different system. But in 2008, in British Columbia, there was a pretty exhaustive review done on the history of building height and area limitations in the code. And what it looked at was that a lot of what's in the building code was developed, again, over 100 years ago at a time when the methods of construction, compartmentation, interior finishes, assumptions around evacuation, assumptions on human behavior, and firefighting capabilities were fundamentally different from what they are today. So when we look at single stair specifically, back in 1941, the first edition of the code allowed 3 stories and 3,000 square feet in non-combustible construction to be served by a single exit. And this is the part where some architects might fall asleep, but it's just interesting to understand how the code has evolved over time on this topic. In 1953, and also to understand that as things evolve, it also means that we are in a moment in time and the code will continue to evolve. In 1953, the occupant load limit was introduced and the floor area was cut from 3,000 down to 1,000 square feet. In the 1960s, the code went through a process of developing principles. So principles for the design and means of egress were ingrained to state clearly, almost like what we have today with intent statements of what the intent behind it is. And one of the principles is that in theory, for any position in a building which might be occupied, it should be possible to travel in 2 directions, since it is unlikely that both will be cut off at once. Ideally, therefore, corridors should have exits at both ends. Now, of course, practically, we have permissions in the code for dead-end corridors. We have permissions in the code for dwelling units to be served by a single egress doorway. And so that principle applies under certain constraints. In the 1970s, travel distance was introduced. In the 1980s, as a bit of urban infill development started to happen, the code started to develop permissions for 3-story townhouses. This is essentially when the stacked townhouse was invented, because it codified permission for 3-story townhouses with balconies not more than 6 meters above ground level. The code also clarified in the 1980 code that dwelling units in buildings up to 3 stories don't need to have a corridor fire separation, so that the dwelling unit is permitted to open directly into an exit, so long as it has a separate means of egress. The 11th edition in 1995 subdivided between sprinklered and non-sprinklered floor areas. That's also the year that the national code required sprinklers in any building above 3 stories, something that was later brought into the Ontario Code in 2010. And in 2005, the entire code system went through a process of going from a purely prescriptive code to an objective-based code, which would enable the use of what previously was called equivalencies, now talking about them as alternative solutions, to demonstrate objective-based code compliance. It's not quite the same thing as a performance-based code, but it's a stepping stone towards a performance-based code. And when we look at the functional statements and objectives, which is always key when you're doing an alternative solution, we can see that the intent is always to limit the probability. To limit the probability relates to risk. Due to hazards caused by persons being delayed in or impeded from moving to a safe place during an emergency, due to risks caused by fire or explosion impacting areas beyond its point of origin, and that both in terms of persons in or adjacent to the building, but also the building itself. So both property and life. What's interesting, of course, is the intent statements that relate to the prescriptive requirement tell us why there was a requirement for 2 exits to reduce and to limit the probability that persons will not have a choice of an alternative exit. In each case, that's restated alternative exit. Of course, the intent statement describes the prescriptive requirement, but the intent statement is not a requirement for an alternative solution, and that's an important distinction to make. What's also helpful is if we look at some of the other intent statements in the code for permissions where you're allowed to have a single exit, it refers to them as on the basis that the floor area has a limited occupant load, restricted area, and travel distance. And so it's establishing the type of criteria and variables that one should be looking at when one is considering a single exit. Another one also states that single exits would be permitted on the basis that occupants are familiar with their egress routes. Right, so distinguishing between residential buildings like hotels versus dwelling unit apartment buildings. And also speaking to the dwelling unit design itself being constrained, and that's limiting the number of occupants. And so if we constrain the size of a dwelling unit, the travel distances inside a dwelling unit, which the code otherwise does not, that's another piece that the code already speaks to as it relates to the intent. So that's a quick introduction to the history of the code, history of single stair in Canada. Now we're gonna step out of the country for a second. We'll jump to a few other continents, and then we'll also look south of the border for a bit. So some of you have seen this document. This was some of the work that I was involved in with McGill University, where we look purely at building height prescriptive permissions in codes worldwide. So every available building code that we could source, asking what is the maximum permitted building height for an apartment building with a single exit stair. Now, one of the criticisms that's very valid of this document is that it doesn't tell you if the buildings are sprinklered, what the construction types are, what the number of dwelling units permitted per story is, all the other variables. But it just speaks to building height. And what's interesting is that there's a large convergence of buildings or countries that allow mid-rise, 4 to 8 story buildings with a single exit stair. And that with the exception of Uganda, Pakistan, and the city of Chicago, Canada is the most restrictive jurisdiction in the entire world. There are also some countries, Switzerland, South Korea, and Japan, that have no maximum building height, but simply define the horizontal constraints and permissions as the building height increases. Now, one of the ones you'll see on here, of course, is the Grenfell Tower. Many people will mention the Grenfell Tower disaster as a reason to be concerned about single exit stair buildings. For those of you that aren't familiar, the Grenfell Tower is an apartment building that in 2017 it was engulfed by the deadliest residential fire in the UK since the Second World War. It cost the lives of 72 people. The negligent use of combustible insulation for the retrofit of the cladding material caused the rapid spread of the fire up the building facade. The tower was a 24-story building. This is an illustration of the Grenfell Tower with its single stair in the middle. The building is 67 meters in height. The scale of the Grenfell Tower vastly exceeds the scale of what's being discussed in the North American context of buildings up to 18 meters in height. High-rise buildings in the UK also have traditionally had a stay-in-place evacuation strategy, which meant that occupants don't evacuate when the fire alarm starts, but instructed to stay in their unit. Partly to avoid an overwhelming and crowding the single stair. But in the case of Grenfell, stay put order lasted for more than 80 minutes from the time of fire department arrival on scene before a general evacuation of the building. Now, obviously, in a building of this height and scale, a second stair would have helped save lives, would have reduced the need for the stay put policy in the first place. But it's important to distinguish proportionality and that the scale of this building is not representative at all of what's being discussed in the North American context. And also in response to the Grenfell Tower disaster, the government announced new fire safety requirements applying to all new buildings, sprinklers being required above 11 meters in height, which is very similar to the 4-story context in Canada. And also introducing a maximum building height for single stair buildings in the UK now at effectively 18 meters. Another jurisdiction that does a good job of diagramming and explaining the rationale and basis of their codes, being very technical and organized people, are the Germans. Germany introduces kind of very clear proportionality and economies of scale for building requirements depending on building height. And so buildings of up to 7 meters, which is the uppermost floor level, so 3 stories, can have a single unprotected exit stair without corridor separation from adjacent floor areas. It also corresponds to the maximum ladder height that is a ground ladder. Once you're going up to 22 meters, the building can have a single unprotected, so no corridor separation. If the fire department has an aerial apparatus, there are no overhead utility lines, there's a parking space clearly designated for the building, the fire department agrees to providing that second means of egress from the fire department ladder. Windows and balconies are placed and coordinated, and all of this is systematically designed for it, which is fundamentally a different context from how we build in North America. The way we task and use aerial apparatus is different. Where we put our utilities and overhead power lines is different. Trees are on our streets. And so it's a context in which expecting ladder rescue or designing for ladder rescue or codifying ladder rescue into our codes the way the Germans do is fundamentally not appropriate in the North American context. What's interesting too is that the German code also speaks to buildings up to 60 meters in height, well beyond maximum reach of aerial apparatus, and states that for those conditions with corridor separation and smoke control measures, a single exit stair is permitted. And then in any building over 60 meters in height, 2 stairs is required. And so again, it's a very clear understanding of proportionality and risk assessment. And here's just another summary of that and a diagram of it in the context of Berlin. And so again, a second means of egress is not required if the first means of egress is what they call a Sicherheitstreppenraum, a fire-separated fire safety stairwell. Now, one of the examples of these buildings built in 2020 is a mass timber project in Berlin. What you'll see is there's actually 3 staircases. The building is essentially 3 small buildings separated into 2 dwelling units per story, each one served by its own stair and elevator core. And one of the things I want to show and highlight here is how narrow the building is. The units are getting daylight from both sides, cross ventilation, and so it's quite a livable and desirable floor plan. I also want to point out it's partially encapsulated mass timber. You can see that about 50% of the walls and ceiling are exposed. The building at 6 stories is not sprinklered, which again is a difference. Sometimes when we talk about single exit stair, one of the things that's pointed out is, and it's very true that in the European context, buildings tend to be of non-combustible construction, but that's also evolving. And in the past few decades, codes around Europe have evolved to be performance-based, and so they are often agnostic to construction type. Last week, I was in a presentation where a fire engineer from Sweden had stated that the mid-rise height, about 30% of their new housing apartment buildings are mass timber, even mass timber with wood frame combination buildings, and in many cases, at that mid-rise height, they're not sprinklered. And so moving over to the North American context, I do just want to mention, I think one of the reasons why other countries have flexibility in their code on this topic is because there's been a long history of building densely urban environments. Perhaps one of the explanations for how we haven't allowed this in Canada is that we don't have a strong cultural and social acceptance of apartment buildings ideologically. And so while the building code is a technical document, it inevitably has a political underlayer to it, which is why there are various exemptions for houses. Certain things tend to kind of feed into it. But even in the North American context, cities in the United States have single stair permissions. New York City has been building this way since the 1930s, essentially since the very first edition of New York's codes. And Seattle developed conditions in the 1970s that have seen hundreds of these 4 to 6 story buildings constructed since. And so here's a few examples of a 6-story building in New York City on a narrow infill lot, a 3-story building in Wyoming, because the IBC code allows single stair up to 3 stories across the entire country, even in a less urban context. A 6-story apartment building in Seattle, and another 3-story in Boston. And then if you squint at the Boston one, actually, it's because it's on a sloped site, it's 3 stories with a basement parking. I probably look at that in Canadian context, say it's a 4-story building. And Seattle's code is an interesting one. Seattle's code has 14 specific conditions related to single exit stair. Now, about half of these are actually just restating what's permitted and what's required by the code anyways, but it's for clarity restated here. But the code language in summary states that it's for buildings up to 6 stories, not more than 4 dwelling units per story, a travel distance of 20 feet from the suite entry door to the exit, which is the exact same as our 6-meter dead end conditions. 1 hour rated construction, same as what we have in our code for buildings up to 6 stories, sprinkled throughout. And that where an interior stair is provided, the stair shall be pressurized. And again, it's not a recent change. It's something that's been introduced in the 1970s. And is right now being considered as an optional appendix for the Washington State Code as well, to allow other cities in Washington State to opt in. And here's a project in Seattle that I think gives a really good sense of proportions and what these types of buildings can be. In this particular case, it's on a street where on the ground floor is the architect's office. It's a co-housing project, so the architects and designers actually live in one of the units up above. And it's a really, frankly, beautiful building. What I want to point out is the typical floor plan. There's units with cross ventilation from both sides. And if we look at this from a smoke spread perspective, the ability for a fire that occurs in any of the dwelling units to spread to the exit stair is approaching 0 because it's got an exterior passageway. And so it's a really intelligent solution for addressing that risk, but also with the courtyard providing better layouts. Another example in Boston, again, this is that 3-story building with its grade level calculation games. In that case, the buildings, again, got 3 dwelling units on each floor. In the Canadian and American codes, an elevator is not permitted to open into an exit. And so a corridor is provided. If a 3-story building like this one in the US didn't have the elevator, then corridor separation is not required. Another example, the Wyoming Workforce Housing Project. It's 3 buildings connected on the ground floor. And in this context, the building does not have an elevator. And again, 3 units on each floor opening directly into the exit stair. And in the US context, if the travel distance is not more than 125 feet, measured all the way down the stair to the exit discharge, then that's permitted. So I'm going to take a quick little water break here again, and then we're going to come back to Canada and look at some recent pilot projects. So over the past 2 years, a series of 10 pilot projects, prototypes, have been developed to demonstrate the benefit and alternative solutions compliance process for single stair in the Canadian context. This work was supported by the CMHC Housing Supply Challenge and led by LGA Architectural Partners. And it was my pleasure to be the project manager on that work while at LGA. I invite you all to take a look at the website singlestair.ca. There's a number of reports, fire engineering reports. You can see each of the pilot projects and its status, a summary of the alternative solution conditions. Again, I'd like to point out that alternative solutions do not establish a precedent. They are site specific. Each one is unique, but they're helpful to understand what has been permitted elsewhere. You'll also see some interesting cost benefit analysis and embodied carbon analysis there too. Yeah, and so singlestair.ca, if anyone's got 2 monitors and is bored of hearing me talk, feel free to take a deeper dive over there. And so one of the projects is a 3-story apartment building, Part 9, building area less than 600 square meters with 10 dwelling units. So 5 2-beds and 5 3-bed units. What's interesting is that on that particular lot, developers would typically design this as a row of stacked townhouses. We know this because we see it prevalently across the province. In that scenario, in the exact same building footprint, that would look like 4 upper 3 beds and 4 ground floor 1 beds. 8 units essentially, and a whole bunch of internal staircases inside each unit. The building wouldn't require a fire alarm system because there are not enough units sharing an exit. None of them are sharing an exit, and the building also wouldn't be required to be sprinklered. Comparatively to that, in the single exit stair design scenario, you're seeing a 10-unit apartment building, 4 units on each floor, and then on the ground floor, 2 apartments. In total, the number of bedrooms that would fit into that building is 4 extra bedrooms and 2 extra dwelling units. And so for market developers that are trying to build and sell, the building at the bottom may make more sense. But for a group like a neighborhood land trust doing a rental building, certainly the apartment building at the top actually makes more sense for their own financial feasibility and financing perspectives. And so this is a quick summary of the proposed alternative solution. The building is sprinklered to NFPA 13. NFPA 13 doubles the water discharge rate and also requires any concealed spaces to be protected. So it's a significant upgrade from NFPA 13R. Again, at this height with 2 stairs, there's no sprinkler requirements. And we know that sprinkler systems are upwards of 95% reliable at containing the spread of fire, containing fires to the room, and certainly the suite of origin. We also look at providing balconies that conform with the OBC area of refuge requirements, and so they're sized to provide a space for all the occupants of the unit. We're increasing the fire separations to be more durable and reliable. We're increasing the fire protection rating and what's called leakage rating. So that's where you're almost like on your car door, you're putting a gasketing around the edge of the door to prevent smoke from spreading through that dwelling unit door. I think what's very interesting in the Canadian context is that dwelling unit doors are allowed to be 20-minute solid wood construction, whereas in other jurisdictions, you're seeing doors that are smoke rated and significantly more durable. And we're also doing the stuff around probability of events occurring, right? So limiting the number of dwelling units, the travel distance, and the floor area of each suite, and also increasing the exit width so that if there's a scenario where people are going up while someone else is going down, it's significantly wider than the 900 millimeters that the code otherwise allows. One of the other concerns is that if a fire does occur within the exit, within the hallway, that the finishes in that space could contribute towards it. And so making sure that all the finishes, ceiling, the walls, the floor, are essentially a very low flame spread rating. And then in this particular case, this one also looks at having an elevator that's opening into the exit stair. Typically, we see elevators that open either into the dwelling units or open into a corridor on each floor. And the code allows that. But what's interesting is that the elevator then actually introduces a risk of smoke spreading between the dwelling units, and the elevator introduces a risk of smoke spreading between stories. Whereas if we can contain an elevator entirely within the exit enclosure so it doesn't open onto any of the other adjacent floor areas, we've actually increased the level of compartmentation in the building. Now, thinking about this not just from a code compliance perspective, but also from a livability piece. This is probably familiar to anyone that's familiar with single stair buildings in other parts of the world. And it goes back to the 1980s CMHC report on this topic, where one of the things that the architects in that had described was that when a stair is directly accessible from the surrounding apartments, it becomes highly visible and familiar feature that the people who live there know well. They know where it is and they know where it goes. It's not a mysterious construction at the end of long corridors hidden behind steel doors. And this may be an important safety benefit for both fires and other types of emergencies. I think that's a really key point, is that the familiarity between neighbors, the familiarity with the egress facilities, the daily use of the staircase at a 3-story building actually introduces an inherent level of responsibility and comfort with that building design. So now we're going to look at a few prototypes. A lot of people have asked for kind of quantitative. Of course, we live in the Western world, so we need to always put data and numbers on everything. We can't trust intuition. And so have asked to empirically quantify the benefit of single stair design for small scale housing. And so what we tried to do with this was to look at small and constrained lots and draw 6 prototypes for 4 and 6 stories in height and 3 stories as well on typical lot sizes across Canada. Having looked at zoning and multiplex permissions, we know that lot sizes typically range from 25 feet to 50 feet. A lot assembly of 2 33-foot lots makes 66 feet. And so what we did was a 33-foot wide lot with side yard setbacks, a 25-foot wide lot prototype where it's on a main street condition, so no side yard setbacks, and a couple of others, again, really trying to capture the full range of major streets and neighborhoods type conditions that we might see in urban areas across the country. And for each one, we designed a single stair design and then overlaid onto it what prescriptive code compliance would require. And so I'll just point out 2 of them that are at the 4 and 6 story range. So this is on a 33-foot wide lot. If you're in Alberta or lower BC mainland, in that context, 33-foot wide lots tends to be how things were configured. The building area is quite a small one. In that particular floor plan, building's required at 4 stories to have an elevator that's stretcher sized. There's 2 2-bedroom units on each floor, and corridor separation is provided because we're above the height of which a ground ladder, so the use of balconies as area of refuge would be possible. When we overlay onto that what the prescriptive NBC code requires, we can see a change in floor area efficiency of 10.5%. When we then run a pro forma, a rental pro forma, we can see that the scissor stair grows to delete one of the bedrooms. And so on each floor, you go from having 2 2-bedrooms to a 2-bedroom and 1-bedroom. Annualized, at rents for a bedroom being somewhere around $500, $550, that adds up to a change in pro forma rental income of over $18,000. And so even in conditions where there may be some additional construction costs because of increasing requirements for sprinkler systems, smoke control systems, et cetera, we have to understand that the floor area savings introduce a dramatic change in the financial feasibility of these buildings. One thing to note here as well is that the code, we're all familiar with the 9-meter separation distance between access to exit. So when you're in the hallway, the 2 stair doors have to be 9 meters apart. But the code actually states that there's an exemption from that as long as the floor area is served or cut in half. So as long as you put a door severing the corridor in half, the 9-meter distance isn't exempt. Another example of a condition of a wider lot, 66-foot wide, with a bit of a bigger building, with a bigger building area as well. In this case, it might be up to 4 units on each floor. Again, extremely reduced travel distances. A mix here could be 3 or 4 3-beds, or we tried to do a bit of a healthier mix of 1 4-bed, 1 2-bed, and 2 3-beds on each floor. And then again, cumulatively looking at what the occupant load in that building is as well is helpful to point out that in the entire building, it's still quite a low occupant load. Now, in this scenario with a corridor that does have the 9-meter separation of access to exits, we're still seeing a floor area efficiency change of just under 5%. But in this particular layout, it really impacts the number of bedrooms that you can provide on each floor. And so the net operating income jumps by quite a significant margin. And what's interesting to point out when you put these 2 side by side, of course, is one of the buildings was significantly larger than the other. And so there's a perfectly correlated inverse relationship between the bigger a building gets in its floor area or building area, the less impactful single exit stair design is, right? If you've got a massive floor plate, you can't do it because your travel distance areas are exceeded, but the benefits are reduced. As soon as you're on a very small footprint of a building, this is an extremely meaningful change in the feasibility of that project. One of the other things that actually CMHC through the Housing Supply Challenge has asked us to look at is what the impact at a kind of macroeconomic scale could be of allowing single stair buildings or shifting towards single stair buildings for the small and constrained lots. CMHC obviously has a lot of economists on staff, and so they wanted to see an assessment like that. With any kind of housing supply projection, there's so many variables that go into that. So I like to call it a bit of voodoo math. So take it with a grain of salt. But I'll walk you through it and just point out that what we calculated was, even though it adds a certain number of extra bedrooms per year as a calculation of housing supply in urban areas, what really it does is provide architects with design flexibility to choose to use that space for extra bedrooms, or choose to use that space for a light well, choose to use that space to make things more generous. It gives breathing room to do a better building design. So the order of magnitude impact analysis, and CMHC had asked us to do this for the whole country, but we aren't really familiar with the zoning bylaws and permissions that exist everywhere in Canada. So we looked at just in the context of Toronto, understanding the length of frontage along major streets, and knowing that the major streets permissions exist for 6-story buildings. That gives us a rough sense of how many eligible sites there are based on an average lot width. If we assume an adoption rate by industry of 0.1% so 1% every 10 years of the eligible sites being developed as mid-rise buildings, that gives us a number of mid-rise buildings being developed every year or over the next 10 years. And then we know that the footprint of the second stair and corridor tends to be about, it's actually close to 20 square meters, but in the most conservative scenario, we took 10 square meters, which is about the footprint of a bedroom. If the ground floor is a commercial use, that's 5 upper stories. So in the most conservative scenario, we assumed 5 bedrooms per building is the impact of it. It certainly show a situation where it's actually 10 bedrooms, but again, being conservative in all our assumptions. And so what that tells us is that over the next 10 years, this change would net just within the city of Toronto on major streets based on the rate of which these buildings would be constructed, 60,000 square meters of additional usable floor area and 6,000 bedrooms that otherwise wouldn't be provided. We then also want to look within neighborhoods at the Yellow Belt where multiplexes are being permitted and do a similar methodology. And so taking the number of single detached and semi-detached houses, applying the same adoption rate of 0.1% of sites annually, gives us 3,400 multiplexes being built over the next 10 years. Interestingly, the City of Toronto Planning Department's own intensification study has much higher numbers than this. I think they're about 10 times higher. Yeah, because it's 87,000 over 30 years. So we're way under on the math. In that scenario, because you're comparing it to stacked townhouses or scissor stairs without corridors, the solution can sometimes be 3 bedrooms, but often just 1 bedroom of change per building. So again, in the most conservative scenario, that's adding up to a multiplex change in overall housing supply of 3,400 bedrooms. So adding that up, again, conservative math on all aspects, we're seeing a net change just in the city of Toronto, just over the next 10 years, that this would yield 10,000 more bedrooms in the city and close to 100,000 square meters in additional usable floor area. Okay, so we now understand a bit about the history, a bit about what's going on in other parts of the world, and I'll try to talk briefly about code change. One of the things is that because the work of the task group is ongoing, and as a member of the task group, we can't kind of do media on the ongoing work, and all of the work is subject to change. I won't be speaking today specifically to the requested code change or where things are at because it's an ongoing topic. But you're welcome to email me and happy to chat about alternative solutions and the code process offline. I just can't do media on the topic right now. But I wanted to just walk through the sort of process to understand how this works. So a CCR, a code change request, was submitted by myself and David Hine Engineering, a fire protection engineer some of you may be familiar with, in 2022. The work was then prioritized for the next code cycle. So the National Building Code is developed on a 5-year cycle. It was added to the list of strategic priorities under housing supply and also under fire and life safety for the current code cycle that we're now in. Then a task group was created. The task group established sub-working groups to focus on risk assessment, fire service implications, accessibility, building maintenance, ES, environmental scan, which is basically a jurisdictional scan with a great amount of detail into every part of what's required in the other codes, impact analysis, so that's cost benefit, and mixed use considerations. And mixed use consideration means in a building with a single stair serving residential occupancy, are other occupancies also permitted in that building as well. The task group and the sub-working groups includes architects, fire protection engineers, building officials, fire marshals, firefighters, persons with disabilities, researchers, and we work together to establish consensus on proposed changes. Now, I'll just make a note on the topic of risk. A lot of us think sometimes around the building code and requirements of safety as being about absolute risk, right? That anything above 0 is unacceptable. But the building code very clearly states at the beginning of it that the intent is to limit the probability of on a comparative basis. And that is what risk is. The severity of something occurring multiplied by the probability of it. And there's a reason why I highlight this. At the NFPA's, the National Fire Protection Association in the US held a symposium for 2 days, specifically on single stair, where they brought together architects, building officials, firefighters, fire chiefs, and regulators from across the US and Canada to talk about this 2 years ago. And one of the slides that the head of data analysis at NFPA put together was this one, which looked at most recent data on the probability of fires occurring and the probability of fire deaths occurring per million housing units, 1,000 housing units, depending on building type. And then this is US data, but in the Canadian context, it's very similar. And what it showed is that a single-family house is 5 times more dangerous than a 3-story or a 4 to 6-story apartment building. And so every time that we can replace a single-family house with a 4 to 6-story apartment building or multiplex with single exit stair, it means we're replacing a building that doesn't have an elevator, is not sprinklered, doesn't have a fire alarm system, with a building that has more housing, is sprinklered, is fire alarmed, has an elevator, and is built to the newest energy codes. And so from a public policy perspective, I feel that this is an absolute win and something that we should be thinking about from a holistic risk perspective. And so I mention this also because, of course, the building code and makes it very easy in many ways to build houses, but adds a lot of costs and complexities to the construction of small apartment buildings. Another similar data set was prepared by Pew Charitable Trust, which looked at age of buildings. So not just the height and type of building, but when it was constructed. And again, sprinkler requirements in the Canadian context were introduced in the National Code in 1995, above 4 stories in the Ontario Code in 2010. And other conditions have kind of ratcheted up and increased the level of performance expected by the code more recently. And so what's interesting here, of course, is that every time we can replace an old building built to an old code with a new building built to a new code, we dramatically increase the level of performance of our housing stock. And so I think I'm almost at time here, but I'll just end by this slide, which is a bit more of a kind of urbanism note. We know our cities are going to grow over the coming decades. Planning policies have evolved to recognize infill development as something that we need to do. We know urban boundary expansion is no longer a good idea. And I know that single stair will help us to do so in a much better way than the current code permits. And so with that, I thank you for the time. Again, if you have any really technical questions or want to know more about alternative solutions and process, I'm going to put my email in the chat here and we'll jump over to the Q&A. So thank you very much.
Great. Thank you so much, Conrad, for the excellent presentation. As you mentioned, we'll now get into the Q&A portion of today's webinar. I see that there's already quite a few questions in the Q&A box, but if you are sitting on your questions, please go ahead and type them in the Q&A window. You find that at the bottom of your screen. And we'll start with just a question, I guess, that I saw twice, whether or not the slide deck will be made available. So it will be made available following the presentation. We will send out a survey to all attendees, and along with the survey, you will get a link to the slides. So yes, you will be able to access those slides afterwards. Okay, so our first question here is from Carl, who asks, how does the BCBC's implementation of more performance-based single exit stair design compare to what you would recommend? And then second part of the question, what about the fast rollout in BC had drawbacks in your opinion?
Well, that's a very good question. And I'm not sure how much color commentary I want to provide or I should provide. So the BCBC code was based on a report that Jensen Hughes, a US-based fire engineering firm with offices in Vancouver, had put together, and certainly developed conditions to define how a single exit stair building could be safe. I think the challenge there was it was done on a timeline that certainly didn't follow the sort of model code process of public review and going through several iterations of stakeholder consultation. And so by the time it was released, there's just a ton of questions from people, even misinterpreting certain requirements in it. A lot of guidance in the appendix notes certainly was open to confusion. And in my own meetings in British Columbia with building officials association, et cetera, often the comment was, we understand what the conditions are and we get it, but we just didn't like the way that this was rushed through. And frankly, that's why, the code change request that David Hine and I submitted wasn't submitted to OBC or to BC or anything. We submitted it to the national model code system because we know we're trying to get towards more harmonized codes across Canada, and it's an important and a big topic, and the national model code system is the right place to discuss this thing. Yeah, so that's about as much. I won't go into any specifics on 3262 pressurization or anything like that, but yeah, I hope that answers the question.
Great, thank you. So we have another question here. In the 3-story model with 4 units and stair in the middle, does the stair lead to the outside? I think that's in reference to a particular diagram you were showing at that time.
Yeah. So if you go on the website, singlestair.ca, you can see all the pilot projects. Again, some of them were developed. Every team had its own architect with its own fire engineer. We knew for this topic, everybody should work with a professional building code consultant, and they developed their own site-specific solutions. And so in some cases, it includes corridor separation. In some cases, it includes mechanical smoke control. Each one followed its own process and analysis. And what we did on the website was we knew that the alternative solution reports themselves are the intellectual property of the authors. But as part of the CMHC Housing Supply Challenge, they gave us permission to just include a brief summary of what the mitigating measures were and the floor plans. So I'd go there to see all the details on those. And then, yeah, happy to shoot me an email if you have more questions.
Great. And I did copy that link, so singlestair.ca, into the chat for everyone if you wanted to access that website. Okay, so someone has asked, can a 6-story building be mixed use? If so, can the GF, I'm assuming ground floor, possibly retail, be larger than 600 square meters?
I'm gonna suggest we skip that question just because
Oh,
it depends.
okay.
Yeah, it all depends on what you're trying to do under the code. Yeah.
Okay, no problem. Okay, so next question here. When proposing an alternative solution, is there a process where the design can be approved in principle before the official building permit application is submitted to avoid potential redesign after all consultants are involved?
Yeah, so I guess that's a question on process. I mean, alternative solutions are at the discretion of the authority having jurisdiction. And so, uh, certainly it's a good idea to reach out early as possible to the building official to tell them what you're interested in doing, to ask them if they're open to having a pre-consultation meeting or a discussion. And some may say, yeah, let's have a discussion. Let's bring in, and certainly in Edmonton, there was cases where they wanted to bring in the fire department, they had a local fire engineer on staff, had meetings before they submitted for building permit. In other jurisdictions in the work on the CMHC Housing Supply Challenge, the response was no, submit for building permit, and then we'll give you feedback once you've submitted. And so that required a whole bunch more upfront work to prepare for that. So it's AHJ specific. I can't comment on the practices in each jurisdiction. But I would say being proactive and also working with your building code consultant, your fire protection engineer, because they'll have relationships and understand what the way is to go about communicating the topic locally.
Okay, great. Someone has asked, wouldn't another prototype be the perimeter block type housing found throughout Europe? In brackets, this makes for continuous street fronts.
Yes, absolutely. What I think we find in the Canadian context is that for someone to have, because of land values, to do a European courtyard block, unless you're on a greenfield site where you've got carte blanche to build something out. But in the context of, typical neighborhoods or main streets, you've got narrow lots. So if you've got enough money to buy 400 feet of frontage, you're building a tower at that point. And so, that's the unfortunate reality of why we don't see perimeter block type housing as infill right now, is because of how high our land values are. But I think there's a huge potential for perimeter block type housing in master planned and sort of, yeah, those types of conditions. But of course, right now, when any Canadian urban planning firm is doing a master plan, they're basing it on a building depth of 22 meters and building areas based on the requirement for typical double-loaded corridor, single or scissor stair design. So maybe that master planning exercise and zoning bylaw building depth assumptions, et cetera, can evolve. It's almost funny because you don't want to have your zoning bylaw be determined by building code. But in this scenario, maybe retroactively a bit of zoning work informed by new building code permissions will be helpful.
Okay. Someone has asked, are there any examples of single exit stair for non-residential occupancy, or is the proposal intended for only residential occupancy?
Yeah. So other jurisdictions, Sweden, for instance, allows you to do 16-story buildings, 16-story office buildings with a single exit stair. Some jurisdictions are agnostic to more flexible on occupancy types. The reason, if you recall, one of the early slides spoke to the intent statement on the basis that occupants are likely to be familiar with their egress routes. And I think that's a key one, is that in an apartment building, you're seeing the floor plan split into several compartments. You're seeing limited occupant load. You're seeing occupants that are familiar with their egress routes. So that's the type of profile that makes sense for this solution. And that's certainly the thing that we're focused on. Is something possible through an alternative solution or for other occupancies? Fire protection engineer can answer that question, but in the context of what we're trying to deal with here, missing middle housing is the focus.
Okay. Someone has asked, what is the benefit/difference between a single exit stair building versus stacked townhouse?
Yeah, that's a great question. So developers love stacked townhouses because you have no common space. You can sell the entire floor area of the building. Of course, the person buying it might not love it that much because they're paying for a lot of staircase. Someone aging in place certainly won't like it because the building doesn't have an elevator. And in other jurisdictions in the US and in Europe and Asia, a lot of three-story buildings, where a site, the zoning bylaw lets you build a certain built form, they're not being done as stacked townhouses. They're being done as three-story buildings with a small elevator because you're getting housing that's suitable for aging in place. And then certainly from a safety perspective, the question said benefit or difference. So that's not just cost. From a safety perspective, stacked townhouses, in my opinion, are the most dangerous and unsafe building type we construct in this country. There's no fire alarm system, there's no fire suppression system, and that staircase acts like a smoke shaft. If something goes wrong in your kitchen on the ground floor, all you've got is your screaming balcony on the third floor. And so anything that we can do to make it easier to build anything other than a stacked townhouse is making the housing stock in this country significantly safer.
Okay. Someone has asked, is single exterior stair for one unit on the third floor allowed in Toronto?
Again, I think I'm not going to answer that one either. It's always dependent on your project. If you're doing, if you're talking about it as a stacked town, or if you're talking about that as trying to do it as an alternative solution, et cetera, it's code specific. Yeah.
Gotcha. Okay. Someone has asked if you provide code consultancy and alternative solutions for OBC.
Yeah, you can send me an email and we can discuss.
Perfect. Okay. I'm not sure if this is a question you can answer, but someone has asked, what is the likely timeline for the OBC to make this change? 2028 to 2030? Question mark.
I have no idea. The Ontario ministers, when it was Steve Clark, announced that this was a priority topic. Then he was out after the Greenbelt scandal. We had Paul Calandra, who announced this was a priority topic. There was an RFP put out and work was awarded, and the province actually scheduled with the OAA a consultation scheduled in December of 2024, I believe, to have stakeholders come and discuss single exit stair. And it was canceled the day before. We happen to have a provincial election coming up. The Ontario Association of Fire Chiefs have some very good lobbyists on staff. And so the consultation was canceled, and we now have a new minister. And since then, there's been no discussion at the provincial level on this issue. And I'm focused on the work of the task group at the national level.
Okay. Someone has asked or said that there is a lot of pushback on changes in the U.S. A lot of the pushback on changes in the U.S. seem to come from fire officials. What kind of perspectives have you heard from their Ontario national equivalents? I guess sort of spoken to that a little bit already, but
Yeah, no, the exact same pushback. What I find is that often it depends on the level of education and familiarity with the building code. So fire officials who are familiar with what is permitted by the code, who are familiar with what is being constructed currently, and who are familiar with the alternative solutions system and comparative levels of risk, who have seen a presentation on this topic, we tend to actually understand it quite quickly and respond positively, or at least respond with concerns, and then are willing to engage in how those can be addressed. It tends to be fire officials who have simply read, a single position paper on it, or seen the title that's been phrased, reducing the number of staircases, that then have an adverse reaction to the concept. And I get that because, in and of itself, having one staircase instead of two obviously is removing that redundancy. But that's not the discussion we're having. We're saying a three-story building with two staircases and no sprinkler system versus a building with one staircase and a sprinkler system. Which one provides better safety? And we can analyze that and come to agreement. And at 4 and at 6 stories, where we're already sprinklering the building, the risk assessment evolves, but those same questions can be asked. So it's always been a question of how much time is the fire official willing to spend engaging in discussion? And then I think generally it's been possible to come to consensus.
We have a question here. So how do the code accessibility requirements play into an SES building where no elevator access is provided?
Yeah, it's an interesting question the way it was phrased. So in Ontario and in all the in all the Canadian codes, as soon as you're a 4-story building, you're required to provide an elevator, stretcher-sized elevator, and the code also tells you in 3317 that where there's a barrier-free path of travel provided, the building shall be sprinkled throughout, or an area of refuge is provided. And so that's the level of performance that's assumed in the code currently for people who are unable to use stairs. In buildings that don't have an elevator at 2 or 3 stories in height, if you're providing a single exit stair, you tend to actually unlock the space and the configuration that you can have an elevator. So comparatively, it becomes easier to provide one. But oftentimes at 3 stories, an elevator just simply isn't financially feasible because they cost so much. And so in those situations, you're seeing the ground floor unit become the barrier-free accessible unit, which has its inherent benefits as well.
We have a question here about light wells. So they said light wells were shown on several of the examples. How could smoke and fire separations be controlled when windows typically have openable fresh air components, particularly with the 0 setback, and possibly have a neighbor's building wall totally enclosing the light well?
Yeah, that's an interesting question. Would really come down to being the specific design. I mean, proximity to exit stairs is addressed in the code. Proximity of an operable window to an exit stair, an unprotected opening to an exit stair is addressed. In this particular scenario, I guess you're asking about spatial separation and adjacency to other buildings. What's very funny in the code is that the code addresses windows that are facing, but for some reason perpendicular is okay. And so which goes back to assumptions and modeling that was done in like the 1950s around unprotected openings and spatial separation. So if I try to answer that question right now, I'll probably talk for 20 minutes. Yeah, that's a long discussion on the basis of spatial separation requirements.
Okay. So sorry, someone has asked here, if a standard double loaded corridor building depth is 22 meters for a double loaded corridor, is there a standard building depth that you expect for single stair design?
No, I mean, sometimes you see in Seattle and actually in Australia, a lot of buildings where it's a barbell. So from a zoning perspective, the building dimension and depth could actually be like 30 meters, but it's because there's 8 or 9 or 10 meters in the front and then a huge courtyard and then another 10 meters at the back. So effectively, you got to measure it as the full depth, but really it's the portion out of which is full depth building depth is much less. In other conditions in Copenhagen and in Berlin, etc., it tends to be much shallower because you're having units with bedrooms facing one side, kitchens, living space facing the other side. Cost of an elevator there is also way lower than it is in Canada, so you could quite easily justify a condition where you have one staircase, one elevator, two units on each floor. And so you can amortize the cost of the elevator between far fewer units because it just doesn't cost as much. Partly because elevators are so expensive in North America, we end up having to share the elevator between more units. And so that kind of courtyard configuration is less feasible. And then also, of course, with our side yard setbacks and stuff, it makes things different. So yeah, I would say it's a great question on building depth, something I've been thinking about a lot, as well as it relates to property dimensions. But yeah, it's pretty site specific.
Okay. Someone has wrote here, so occupants being familiar with egress routes Does it mean so long as the stair is being used as the main/regular circulation route, it could be considered for non-residential occupancies?
I'm not going to answer that question because, right now, single exit stair buildings are not permitted beyond 2 stories in building height. This concept of doing single exit stair for residential buildings, not all residential buildings, just dwelling units, um, is on the boundaries of, what's it called? The Overton window of acceptance in the Canadian context right now. So even having discussions about non-residential uses being permitted by a single exit stair at a time when we haven't yet codified in Ontario permissions for residential, I think is a bit premature. It's not to say that you can't work with a fire engineer to develop performance or an objective-based design for what makes sense, but I certainly won't comment.
Okay. This is a great question. So someone has asked, how can we as architects/members of community advocate for this since it is clear this can greatly improve our downtown urban fabric, improve safety, and provide more aging in place friendly environments to keep a well-maintained city environment?
Yeah. I mean, what's I think been helpful is, first of all, seeing that this is something that architects specifically, not the development industry, but architects have been advocating for since the 1980s. In British Columbia, there was a number of architects locally in Vancouver and in Victoria who had really championed this topic, and that's what helped get the province to listen and take it seriously. My focus is on alternative solutions and on the national codes process. And so if there's an interest in this topic being something that's prioritized and thought about in Ontario, the more architects talk about this, the more that it's brought up in through alternative solutions and discussions with local AHJs, in discussions with your clients, in discussions with organizations that are interested in housing topics. That just helps being understood as something that there's a general consensus amongst our industry is a good idea. And certainly what I've also noticed is, in the US, for instance, as this topic has been talked about a lot, in Texas, it was really helpful because there was a group of local architects and planners in Texas that took it seriously. They didn't want to listen to someone from New York talk about it or someone from Seattle talk about it. They wanted to hear from their own people locally that this is something they think is a good idea. And so we tend to be provincial in that sense. And I think that's okay. The other thing I would add is, so the National Model Code System does have priorities for every code cycle because they can't address everything all the time. And so they have to manage what they're going to look at in every code cycle. But I mean, we submitted a code change in 2022 and in best case scenario, it'll be codified for 2030. So if there are things that you're seeing are challenging on projects you're dealing with, that's not magically going to be solved by the National Model Code System. That requires architects proactively being engaged with the code system. And it's not that complicated to submit a code change request. I certainly can email me about code change requests and how that works. And so if there are things that you're seeing in the codes that you think are problematic, the code system relies on engagement from people to submit to it. And often they get code change requests from non-architects who do a pretty poor job describing the problem and how it could be addressed. And so I'm actually quite surprised at the general lack of engagement from architects with the code system, knowing that this document is essentially the Bible we have to work with every day. So that would be my biggest comment, is not even just with single stair, but other topics around building code. It's a slow process, it's a long process, but it needs architects being involved with it. Otherwise, change just doesn't happen.
Okay. Okay, sorry. So someone has asked, this is a clarification question, I guess. So presently we can have single exit stair buildings up to 2 stories. So the future goal is to allow up to 6 stories, correct?
I would answer that as that's my goal. That's what the code change request submitted for. And the terms of reference of the work of the task group is to look at buildings not more than 18 meters in building height. And that's public knowledge. So
Mm, okay. Someone has asked, are the proposed changes including the requirement of the buildings to be constructed as non-combustible construction?
okay, so I will say the code change request did not specify construction type. It's agnostic to construction type. British Columbia's code and Vancouver's code does not specify construction type. It's agnostic to construction type. But Vancouver did recognize that the exterior exit stair and exterior passageway had to be of either mass timber or non-combustible construction. So that could be a steel or mass timber solution, but not a wood frame staircase. However, the floor areas adjacent could be wood frame. So yeah, other codes in Canada, agnostic to construction type, code change request, agnostic to construction type. What ends up being codified and recommended by the working group and the National Model Code System is an ongoing process.
Gotcha. Okay. Someone has asked, do you have a community research lab that we can apply or join as volunteers to help with research and advocacy?
Not sure what a community research lab is, but it sounds like fun. It sounds like a place that I'd like to hang out. You could send me an email and let me know what you have in mind. Yeah, I don't know if I see a bunch of people asking for the email address or if Shalika, I don't know if it went in the chat, but just it's simple
Yeah.
Conrad, Conrad at semibold.ca.
Yeah.
Don't want to do anything too bold. I like fonts a lot, so nothing medium or regular, nothing italics, nothing bold either, just semi.
Semifold. Gotcha. I wasn't sure, yeah, where exactly that came from, but now we know font-wise. Okay, great. Okay, I think there's just a few more questions which we can take in our remaining time. So, someone has asked, is the prototype in on the singlestair.ca website, is that based on Toronto Major Street bylaw? They say the setback requirement in the bylaw is more restrictive than the prototype, for instance,
Yeah.
5.5 meters for all portions of the main wall that have primary windows, etc.
Yeah, so if you click on the website under prototypes and you scroll down, you'll see some clarifying statements on why we did the designs without basements, yeah, sort of the assumptions around it. So we didn't design to any particular bylaw. Certainly, we took a bit of inspiration from some bylaws, and bike parking rooms there might have been accidentally sized to be similar, but it was a generic design feasibility study level thing, certainly much like a housing catalog, not something that you can go and copy paste, but is something just to be inspired by. It's a glorified Pinterest board.
Okay, perfect. And our last question, someone has asked, has there been discussion about single exits there that does not require sprinklers? For smaller 10 to 12 unit builds, sprinklers present a significant cost burden. Given that you are proposing an increase in FRR, is it possible to remove the requirement for sprinklers?
Yeah. Yeah, I think that's an interesting question. Any jurisdiction that has codified single exit stair buildings in North America, so if you look at the US model codes, Vancouver, British Columbia, they require the building to be sprinklered. So that's the sort of precedent that's been established in the Canadian and North American context. Sprinklers are extremely reliable at reducing fire spread beyond the room of origin. And so something that a fire chief had said at the NFPA symposium that stuck with me was number one goal in fire safety is to prevent fires from occurring, to prevent fire events. So how can we do that? We make the building small with less people, with less kitchens, with less people and less kitchens. The second priority is to prevent the fires from spreading. And so we do that with sprinkler systems, with well-rated closures and fire resistance rating and fire separations. We do that with compartmentation and suppression. And then the third level in that hierarchy, right? Tertiary, not equal, tertiary, is ensuring that we get everyone out And so having redundancy, having alternative means of egress, an alternative exit benefits that. And so in that hierarchy, if we can do things like introduce a sprinkler system, we decrease the need for that tertiary measure. An increased fire resistance rating of a wall assembly doesn't do anything to stop a fire from growing and to stop smoke from spreading. So that's one of the things that has to be kept in mind. Yeah.
Okay, great. So I think that's our last question for today. So we will close off our webinar. I have a few quick announcements. So before I do that, of course, thank you so much to Conrad for this excellent presentation, and thank you to all of our attendees for your excellent questions and discussion today. Again, a few quick announcements. For those who are seeking continuing education learning hours, again, the OAA will record your participation in this webinar on your OAA transcript. So there's no need for individual reporting on your part. We just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. Attendees will soon receive, as we mentioned, a link to the presentation slides, but also a link to a survey to submit your feedback for today's webinar, which we and our presenters highly value. So please do take a moment to complete that survey once you receive the link. Our next webinar takes place tomorrow, Thursday, April 2nd, with the title Continuous Insulation Compared Within 6 Steel Stud Framed Wall Assemblies. And this one is presented by George D. Schoenhard. And if you are looking for additional ways to get your Con Ed hours before the end of cycle, be sure to check out the Con Ed opportunities page on the OAA website, where we list continuing education opportunities offered by other organizations beyond the OAA. So with that, I thank Conrad and I thank all of our attendees once again for your attendance, and I will wish you a pleasant remainder of your day. Thanks very much.